Hello, folks. My name is Jonathan, and I'm here to show you this new issue that I created yesterday on RubyGems. So this is a long discussion that the RubyGems already have in the past, and the idea here is we try to bring some statistics about the gems that can help the authors to also know how their gems are being used and installed. So if you go to rubygems.org today, you can see here we have this huge amount of billions of downloads. And then if you go to a gem, for example, I have my gem that's fast. So if you come here and say fast, you can see we have this total amount of downloads and we have like a total for this version. And that's all the statistics that the gem have. And the idea is that we can also provide more time series statistics, like how many downloads do you have per day or per week when it starts coming more data driven for everybody, for all types of business. That can be a very good thing to have. So that's one thing to do, and that's the task that I'm going to be tackling in the next few weeks. So the idea is just come here and bring implementing this. So this first video, I'd like to just introduce the timescale to the stack and start setting up something here. So as you can see here, Samuel already did some work in the past. So a lot of work here that I'm going to do is something that is already done by Samuel. So I'm going to try to introduce these steps and also introduce you to the RubyGems stack and everything that you need to know to start contributing to RubyGems. So this is my first contribution. I would like to try to document my journey on trying to contribute, what types of things I'm struggling, what types of new things I'm learning, and trying to be very, let's say, engaged in this community and also help to document some of these steps. So I am almost 20 years working with Ruby. I love the language. I feel really flying with this, and I hope I can I can teach you something while I'm coding this. So let's start our journey. First thing that we need to understand is where we are, what we have, and how we can improve what we have. So let's start breaking down these things, and then we can start also working with the entire thing here. So the first thing that's very important to understand here is that we already have a model here that serves as the base. So let's jump into the code here and let's get here into download gem. So the gem download is already representing the counters and doing everything, but this is not like a time series style. So this is just like counting, and then we have several records that we can say from this to that, and that's how it works. So if we go to DB schema, we can just see here what's the gem downloads. So we have the Ruby gem, and then we have the version, and then we have the count. So this is a single record per Ruby version, right? We also have a way that we can download the dump here. So if you see here, we have scripts, we can load pgdump. So this is a very nice thing that we can be doing. So here it expects to be like the RubyGems database and also the user Postgres and download. So probably these users are coming from the service that should be running here. So here the service is just using the Postgres image, and I I know that the RubyGems team is already working on a lot of things, so we are not going to mess with the actual DB, but we can just introduce a new DB running on a different part, and then we can also just run it in parallel as a secondary database. In the ideal scenario, we could just come here and just change it to timescale slash timescaledb, and then we can also say here high availability, so we can get this image. let me copy this. That will be much faster. Yeah, so we can just use this. So as we are not going to do exactly this thing, so let me just copy and paste here, and let's revert this scenario. So oops, let me come back here. Yes, and I just paste it as timescale now. And then I can just say here that we are going to have a different part, right? So, and with this thing now, we can just start running the app. And so let's try to start Docker Compose here. Okay, it will be pulling things up, and also let's see if it will install the timescale as the secondary DB. While it's installing, we can also take a look in other stuff that's happening here. These images and everything that is related to the actual task, we can take a look. So I think we are done with the image here. As soon as it starts the image, it's already pulling it. So probably the command is good. It's okay. And now I would like to go to show you how the data comes and what we parse from that and how it works. So first thing that worth highlighting here is that the gem downloads is using this weird method that's just like a simple way to track the totals. So if you see like a RubyGems with version 0 and RubyGem ID 0, that is the counter, the totals. So we keep the totals in some record, and then we keep the totals of the totals for all of the gems with the version ID 0 and RubyGem ID 0. And the RubyGem ID that has the ID, but the version ID 0 is the counter of that gem. So as you can see here, for that Ruby gem, so it will just say for version ID 0. So it's the way that you can keep the counter, and that's like a very smart way. But with the idea of time series data, we go in the opposite direction. We go in the direction that we just try to get the most granular data and store it in the database. And then later we can just build more, let's say, continuous aggregation to just say, well, we have this amount per month, we have this as a total, and that's how it works. So we are probably going to introduce a secondary model, but I would really like to just load this dump and start exploring it more seriously here, and also show you how it works. So we are still pulling the images. It's yeah, I'm getting the largest image here because this is a HA image. It's more complete. It has also TimescaleDB toolkit that can allow us to do several types of extra aggregations and stuff like that. So I think the next part we can take a look while it's running is the Fastly job. So let's just go to Fastly log processor. So Fastly is the CDN that delivers all the Ruby gems across the network. So this is a fast way. If you go to the actual issue that I mentioned before, you see some comment that Samuel did about the nature of CDNs and how the pipe package is exploring the same. So if we go here, you can see that it's very hard to make these statistics fair because they are depending on the CDN. And this is very interesting. Here is how you can do it with pipe package, and we are going to build something similar, right? So the main idea of the Fastly log processor is that we can count the amount of downloads per gem, and then we can process this data, and then we can do something else. So if we go to the test of this file, so let's go to test fastly log processor job test. This is the file that contains the tests, and this is getting this fastly fake log. So let's go to the file directly first. So fastly fake log. So this is what we get from 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 Fastly, and this is like some date here and some IP, some remote IP, and we can also see here that what's the path that it's getting and what's the gem that's being downloaded, and then we also have the agent here, and I think probably we have a place which we have a kind of number here. I can imagine that we need to have like 200 probably means that it's okay. It's returning, but yeah, yeah, we don't have a number. So that's really great because it seems like this is very granular. If this is really granular at this level, we can just save everything as a history, and then we can collect such data later and just break it down. So we can extract here the agent. That's quite important. Like the RubyGems here is the one that is getting the file. You can also see like the architecture of the machine, the Ruby version, and the patch level, and so on. And I was expecting that we had kind of a different way that we have counters, but here, as you can see, JSON 1.8.2 is just getting 4. And so when the processor gets the file and creates the import, it will just try to assert it in the proper way. So let's just double check this. This looks very interesting and quite easy for us to also understand and debug. So the first test here that is in the top is the one that probably can help us to understand. So simple log counts is being verified when we update, and we just verify if the values are okay. So that's really what we want. So this is the most basic thing that we want, is expect that this is the right count. So let's go in with these JSON ones that we have two cases and 1 and 4, and that's how it's going today. So let's see here. 182 we have 4, and this 304 is also probably like a valid, but the 404 is not a valid. So it's 182, and this is returning 4. So probably this is also like skipping this status. So let's go to the processor and let's learn this. So where is the file being read? Path pattern. Okay, so here is the file, and here is the response code. In case the response code is okay or not modified. Okay, nice. So that's the true that we are doing. So we've matched the pattern, and then from the match we just accumulate. So that's how we do it, and then we just create a hash which we can log the OK status here. So download counts will return this small hash map with the version, and here is how we are capturing it. So I see that we have a good opportunity to just create a new job and explore it as a new entire thing. And I also advocate for this here. Like I create this idea that says extract downloaded gems and introduce a clone of Fastly job that just stores the data on TimescaleDB. So we are not going to introduce anything there. We are just going to add a new job, and then we can just start piping and parsing these files and piping the data to timescale, and probably we can make it in a very granular way and get much more insights from this data. Okay, so that's where we are going to start. Okay, we have things running here. DB1 is not running. Probably port is already allocated. Okay, that's fine. So probably if I say here, Docker PS, I have everything running. The only thing that's not running here is the the same port. So let's just fix this thing. So here we have the port, the ports going to 532, and this is complaining that I cannot use the same port. Yeah, this is a very little issue. So let's just cannot start the service DB because okay. So uh, it looks like none of the DBs are using this port, but we can always use my favorite healing port. And for some reason, this looks like another thing. Like I did Docker stop before, and then now it's just stop it. Let me just start Docker again. Yeah. Okay, Docker is running. Let's go and just say Docker compose up. So it's complaining about the DB and not complaining about the timescale one. It's interesting because probably this part is the problem. So I will try to just to do it Postgres port equal this one, and then let's see if it will not complain again. Okay, now it recreates. Let's try one more. Yay, cool. Now it's running everything. And now you can see that's the magic of try trials and trials. Okay, let's go, let's go. So now we have it running. So if we go here and I'm just going to start new, and then here we can just say bin slash, oh sorry, scripts load pg down, and then -c for download the latest. Okay, so I just need to say -c and say dump here, for example. Oh, let's get this. This line looks the one that we are looking for. Oh, oh, it's not script. Sorry for my, yeah. Yeah, so now we are downloading the latest file and we are going to load it into the database RubyGems development. So do we have this database? Not yet. So now we need to also create this database in this scenario. So let's just use here rakedb create all and let's go. I'm not saying that we are going to create the TimescaleDB here because we didn't set up it, but we are going to set up it later and we can just create the RubyGems part now. So now you can see, let's go. Oh, I am just too bad because I don't have my user in this database. So I just go to the database, create user per user, and then probably we can try it again with my new super user. Okay, it says now, did you create the database? Oh, I need to create the file vim config. I will just copy. Oh, we have it. Hmm. Seems like we have a timescale connection here. Maybe we already have something implemented. That's, yeah, I don't know where this timescale part comes from. Maybe I mess with my actual master. Maybe that's something that I still need to fix. I was really not expecting for it now, so it was funny to see. I will even go to master just to confirm that it's just something that I am imagining or not. So config slash database. Oh yeah, database is not here. We just have the sample. And that's my file. That's something I was trying before. So I will just get this raw file and start from this one because this is the one that, yeah, just a sample. Just copy and start from the sample again. So let's do rakedb create all again. Okay. No database errors. I could not find your database RubyGems development. Okay, let's try bringing Rails DB create. Maybe I'm just trying the oops, maybe I'm just trying the old school thing here. And okay, now I have the database. Okay, and now we are already creating all the data inside. Oh, that's so weird. It added a lot of things here, and then for some reason, dropping tables. Okay, okay, let's try again. Something is not working. Let's see. Oh, I don't need to download it again. So I can just say this part. That's really weird that it looks like it's just using another socket here. And I think that's because I need to say here minus h dot 0 dot 0. Oh, minus h is yes. Now we go. Here we go. Let's see. Now we are inserting the data, and this is amazing when we see this type of open source thing that even the data is open. I love it. So the drop cascade. We have a problem here. Error trying to open the file. Oh, I have a problem with the way I build this. So it seems like this is repeated. And for some reason, it was just trying to use it again. So let's rerun to warranty. It's cool. We just drop the database, create it again, load everything. It's fast and we can just run. Okay. Okay. Unexpected end of the file. Now I have a really serious problem. Yeah, we are just in the outer table. Probably the file that I downloaded didn't work as expected. So let's do it again. Let's download the entire file and try to run everything just to guarantee. And oops, I thought I selected to download latest. Load pgdump. Okay, so you just say where you want your file, script load pgdump, the name of the DB, minus h. Okay, in theory, that's what we need to do. But the thing is that my file is corrupted. I need to just to erase this file. So let's download another one. Let's see if it will download. It seems like for some reason it was really not fetching the file. Hmm. Load pgdump, download the recent file. I need to say here minus C to say that it should get the file. Fingers crossed, it's from 22. So here we go. Okay, folks, let's wait until it downloads and we can get back to it soon. We get the downloads going.